دیگه عالی قسمت خواندیم دوستا و فعلا برادکاست وان یونیکاست برادکاست و مولتیکاست دیگه ایره شروع میکنم.
Domain. In networking, we have what are called unicasts, broadcasts, and multicasts. A unicast is one-to-one communication, so one device talking to one device. A broadcast is one device talking to everyone. So when a broadcast is sent onto the network, who receives it? I'll get into the details in a separate video, but basically it's a message going to everyone. A multicast is a message sent to a subgroup of people. So as an analogy, think of email. When I send an email to you, that's a unicast, one person talking to one person or one device talking to one device. A broadcast would be a message sent to the entire company, so an email sent to everyone in the entire company. A multicast is like where you subscribe to an email newsletter. So only some people receive the email, not everyone receives the message. When PC1 over here sends a broadcast, that's received by everyone in the network. This is a single broadcast domain. Single collision domain, and single broadcast domain. Now, just like with a bus topology, this is a single collision domain. If PC1 sends traffic to PC4, and at the same time PC2 sends traffic to PC6, a collision is going to take place, and that affects the entire network. Remember, this looks like a star, but acts like a bus. This is also a single broadcast domain because a broadcast sent by any one device is received by all the other devices in the topology. Again, this looks like a star but acts like a bus network. Broadcast, unicast, doesn't matter, multicast is sent to everyone in the topology because when a hub receives traffic on one port, it replicates the traffic out of all other ports. Single collision domain, single broadcast domain. Not great. Now, after hubs, bridges were developed, and this really changed networking. Here's an example of a
bridge. Okay, let's go for bridge. BRI
bridge. Switches are very similar to bridges in that they learn where MAC addresses are in the topology. There are differences between a bridge and a switch, and I'll talk about that right now. But first, I want to show you that bridges actually existed. This is a physical bridge. People sometimes complain that I show older devices in my videos, but understand that even today, in a very modern switch like this, a 9200 series switch, it still refers to a root bridge in spanning tree. So you'll see the term bridge in spanning tree, and that's because spanning tree ran on a bridge like this. Bridges and switches learn where devices are in the topology. They learn the MAC addresses of devices and only forward traffic out of specific ports based on where the MAC address is. Huge improvement in networks. Some differences between bridges and switches is bridges do things in software, switches do things in hardware. They have what are called application-specific integrated circuits, or ASICs, allows them to move traffic very, very quickly in hardware rather than using a central CPU. On some switches, traffic can be moved from one port to another using chips directly on the ports rather than going to a central processing unit. Whereas on a bridge, it was done in software. Everything had to be done by a central CPU. There are also fewer ports on a bridge. So as an example, notice this bridge only has 2 ports, whereas this switch has 24 ports. So you'll get 24 port 48 and switches with many, many more ports today. More ports on switches works with hardware. Bridges, fewer ports, uses software. They both, however, use MAC addresses to discover where devices are and then forward traffic according to the MAC addresses that have been discovered. That reduces the collisions in our network and gives us greater throughput. So if PC1 sends traffic to PC4 as an example. Let's assume the MAC address of PC1 is A, MAC address of PC4 is B. MAC addresses are 48 bits in length, written hexadecimal. I'll just keep it very simple here. PC1 sends traffic to PC4. The bridge will learn where the MAC addresses are of the devices. Initially, it will flood the traffic out of all ports until PC4 replies and the bridge learns where the device is. But once it's learnt where devices are, all traffic sent from PC1 to PC4 is only sent out of this port. Let's assume it's port 1, 2, 3, 4, 5, and 6. Traffic is only sent out of port 4. PC5, PC6, PC2, and PC3 do not see the traffic sent from PC1 to PC4 because the bridge has a MAC address table and has learnt that A is on port 1 and B, the MAC address of PC4, is on port 4. And excuse my bad handwriting. Hopefully that makes sense. At the end of the day, traffic is sent directly to that device. When PC3 sends traffic to PC6, once the MAC address table is updated, that traffic is forwarded directly between those two devices without interfering with others, and the same is true for PC1 and PC4. So in a topology like this, if a collision takes place, it doesn't affect the entire network. And we actually have here 1, 2, 3, 4, 5, 6 collision domains. It is, however, a single broadcast domain, because if a PC sends a broadcast, that's received by everyone in the topology. So 6 collision domains, a single broadcast domain. Now switches are very much the same as bridges. In a topology like this, we have 1, 2, 3, 4, 5, 6 collision domains. A collision on a link here only affects that link, doesn't affect the other links, because the switch, just like a bridge, learns where everyone is in the topology and only forwards traffic out of certain ports. If traffic is sent from PC1 to PC4, just like a bridge, the traffic is only sent out of the relevant port once the MAC address table is populated. We'll talk about that in a lot more detail later, but basically the switch will learn that A is on port 1, B is on port 4 in a topology like this, and will only forward traffic out of the relevant ports. When traffic is sent from PC4 to PC1, it'll only be sent out of port 1, because the switch has learned where devices are in the topology. But just like with a bridge, this is a single broadcast domain. If a broadcast is sent into the topology, all devices in the network receive that traffic. So every device here will receive the broadcast. The broadcast is sent out of all ports except the port in which it's received. So this network consists of a single broadcast domain and 6 collision domains. I'll be showing you that practically in more detail later, so that you can actually see how the traffic flows in the topology. For now, just try and get an understanding of how this works. A big advantage of switches, and why we use them, is they give us many ports. In other words, we can connect many devices to the network. You get different sized switches. So as an example, this switch only has 8 ports. This switch has 24 ports as an example. Again, you get switches with many, many more ports. But these switches at the top are examples of unmanaged switches. These are managed switches. Unmanaged switches tend to be a lot cheaper than managed switches, but you can't change the configuration of the switch. You get it as it was made by the manufacturer. This is an example of a Cisco switch. This is a TP-Link switch. You simply plug in your devices. The MAC address table of the switch is populated, and it learns where devices are in the topology, but you can't change anything. But works a lot better than a hub or previous.
Is bridging computer network. Bridge the networking device in a computer network that is used to connect multiple LANs to a larger LAN. In computer network, we have such as routers.
Technologies. With managed switches,
The bridge. What is? What is? Oh,
Managed switches tend to be more expensive, but give you the option to configure them. You can change the configuration of a managed switch. So as an example, you could, and we'll talk about this later, create what are called VLANs or virtual local area networks, where you stop broadcasts from going through the entire switch. So you could say these ports belong to one VLAN, these ports belong to another VLAN. Broadcasts sent on these ports stay here. They don't go out of these ports. Don't worry too much about that. Lots to cover. Moral of the story is managed switches allow you to change the configuration of the switch to give you better security. To manage traffic better. Unmanaged switches, you get what the manufacturer has given you. You can't change the configuration, but give you ports so that you can expand the size of your network. Now, routers do many things, but one of their most important jobs is to connect our local network to other networks. The whole
Okay. خب ما در چیکس خواندیم یونیکاست، برادکاست، مولتیکاست. is one-to-one communication where one device is talking to one device. که یونیکاست همون هست که فقط یک دیوایس به یک دیوایس صحبت میکنه. و برادکاست one device is talking to everyone. فقط یک دیوایس به همگی صحبت میکنه. A message multicast. A message sent to a subgroup of people. و multicast شما هست که مثلا همون یک پی سی یا یک خب مسیج هم اینجا باشه پی سی هست دیگه. یک پی سی با ساب گروپ یعنی با گروپ از مردم صحبت میکنه. What is a bridge? What is switch? Bridge و switch اردیشان یک رقم است و اردیشان هم از مک آدرس ما دیوایس ها یاد میگیره که یعنی از کجا ما ترافیک ارسال کنیم. نیاز نیست که هباره یعنی به همه پی سی ها ما معلومات ارسال کنیم. نیاز نیست. فقط ای یاد میگیره از امو مک آدرس فیزیکال آدرس و بعد از او باز از طریق از امو ارسال میکنم و چیره مو معلومات یا مو پاکت دیگه. ما سویچ داریم، دو نوع سویچ داریم، یکی منیج و ان منیج. منیج دمو هسته که میتونی تو کنفیگریشن مثلا کده میتونی قسمه که گفت مثلا virtual LAN میتونی virtual local area network میتونی بسازی که بگویی که مثلا اینی لان مربوط مثلا اونجا گفت کجا شد مثلا اینی ورچوال اینی قسمت مثلا نیاز مثلا اینی جداست و اینی جداست، اینی ترافیک اینجا رو نیاز نیست اینجا ارسال کنی و اینی یک از منیج کرده میتونیش، یعنی میتونی کنفیگریشنش منیج کنی و ان منیجدش نه چیزی کرده نمیتونی. ان منیجدش هم ارزان تر است و اینی بود چی ما حال میم سر راوتر که راوتر چی است.
plug in your devices. The MAC address from other networks. So in a topology like this, we have a router that connects us to the internet, and the way that that connection is done can be different. As an example, something that's become really popular recently is Starlink. On the Starlink router, I have an Ethernet connector. So I could connect my laptop, as an example, to this connector. So this is connected to the satellite dish and to the Starlink router. But you may want to connect this to an Ethernet switch, such as this switch, to give you more ports. So rather than connecting to the Starlink router using just Wi-Fi, you could connect to the Starlink router using Ethernet in a similar way to what I've shown here. So as an example, this could be our Starlink router. This is the internet. We're accessing that through satellites. So here's an example. I've got the satellite dish that would connect us to the internet via satellites. And on this side, we've got an Ethernet connection to our switch. And then we can connect multiple PCs to the Starlink router. We could do that using Wi-Fi, but you may want to run multiple access points or more devices using Ethernet, and that's what this gives you. So that's very typical of a home network. You may have something similar at home where you have your PCs connected directly to a switch or directly to a router that connects you to the internet using something, which could be, as an example, satellites. It could be 5G. This is a 5G router. Here's a Cisco 4G router. So in the same way, I could connect my switch to this router on the LAN port or local area network port. Allows me to connect the 5G router to a switch that gives me many, many ports. And then the way I get to the internet in this case is 5G. Or on the Cisco router, as an example, it has some built-in Ethernet ports. I could expand that with a switch, and this connects me to 4G. So this is a 4G Cisco router. Or in this example, with this Cisco router, it has an Ethernet WAN port. So in that case, you may be connecting to fiber. You might have fiber to your home, as an example. Or on this router here, it has a DSL port. So you'd connect a telephone cable here. So you'd get access to the internet using ADSL as an example. This is an 8200 series Cisco router, much bigger router. And once again, the way that we're going to get to the internet is via Ethernet. So this would need to connect to a modem that provides fiber as an example. So the basic idea here is my router allows my local area network or LAN to connect to the WAN or wide area network using some kind of technology. It could be Starlink.
Area. Okay, and one wide area network. Wide, wide area, right? Area network.
It could be 5G, it could be fiber, it could be a telephone line. There are lots of options, and in the old days, we used to use serial links as an example, or leased lines. So you may still come across that in your studies or in the real world. Serial links have been replaced in many cases with Ethernet and other technologies. Now, a company may have many sites. Here's an example with just 2 sites. We've got PCs connected to a switch, say switch 1, which in turn is connected to router 1, which in turn is connected to the internet. Here's another site. We've got router 2, switch 2, and some PCs. The idea here is traffic is routed from one network to another. So routers route us from our network, for instance, to the internet. And the internet is made up of many routers, many routers in the internet with lots and lots of routes. But the idea here is we are routing from our local network to the WAN. And on this side, we route routing from the WAN to the LAN. So we've got a LAN this side, we've got the WAN or wide area network, and on this side we've got another LAN. Now from a traffic point of view, important to note that each interface on a router is a separate broadcast domain. If broadcasts are sent by any of these devices, the router will not forward the broadcast onto the internet. And in the same way, if a broadcast is received by router 2 on this interface, that broadcast is not forwarded to the local area network. Every interface that's a routed interface on a router is a separate broadcast domain as well as a separate collision domain. Now, the world these days is kind of blurred. Here's an example of a home router running ADSL and some Ethernet ports. One of them is actually marked as LAN WAN and the others are LAN. This is a router, but it acts like an access point with Wi-Fi. It acts like a switch in some ways because traffic on the LAN is switched between ports, but then routed to the WAN interface, let's say this interface. On a Cisco router, something similar could be done. On this router, these are switched interfaces, and these would be routed interfaces. So depending on the router, and it also depends on the switch, some interfaces can act like a routed interface and some interfaces can act like a switched interface. Router interfaces stop broadcasts. Switched interfaces will forward broadcasts. What is this device? This is a firewall, or as Cisco call them these days, a Cisco Secure Firewall. This specific device is a Cisco Firepower 1010, a little firewall, but notice it's got some switch ports on it that allows you to connect to the internet using an Ethernet connection. Firewalls essentially protect us from bad actors or bad people trying to hack into our network. Now, in a home environment, as an example, you may have a little router like this. And again, this is what gets confusing about home routers like this. They combine lots of functionality. This typically has a built-in firewall, but how good that is really up to debate. It's a router, it's an access point, it's a switch, and it's also a firewall. Now, this may be okay for some home users, but in an enterprise or larger business, you're going to want to have a dedicated firewall. And this obviously is a very small firewall in a small or medium-sized business or branch office. Very small firewall. Cisco have much larger firewalls than this for large enterprises. A device like this these days has a lot of intelligence built into it. You can do simple things where you say traffic is allowed from your inside network, so your secure LAN, to the WAN or the internet, but traffic is not permitted from the internet to the LAN unless it's an answer to traffic from the LAN to the internet, or what we called the inside interface and the outside interface. So in a network like this, you may have some PCs connected to a switch, which in turn is connected to a router, which has a firewall in front of it that connects you to the internet. Now, this is possible if you, for instance, got fiber to the office or your home, and you are connecting the firewall via Ethernet to your modem or device that your ISP is installing at your premises. Now, that's not always possible because this connection could be something else than Ethernet. What happens if this is ADSL or some other type of technology? Maybe using Starlink, or what about 5G, something else for this connection. In that case, the firewall is connected to the router and the router connects you to the internet. So again, this could be a 5G router, this could be a Starlink router. Some kind of router is used here that gives you physical connectivity to the internet, and your firewall is behind your router. So traffic arrives from the internet, as an example, is sent to the firewall, is permitted or denied to your internal network. This may be your outside interface, and this may be your inside interface. And you may also have something here, like a third interface, which is your DMZ, where you have servers or other devices that people can access through the firewall. The physical installation of firewall behind router or firewall in front of the router really depends on what kind of internet connection you have and whether you want the router to be in front of the firewall or the firewall in front of the router. So it's really up to you how you decide to install this, but a big determining factor is what type of connection do you have to the internet. This couldn't connect to Starlink directly. You'd have to connect this to a Starlink router, which connects you to the satellites and the internet. Now, one of the features that a firewall may have is something called IDS, or Intrusion Detection System, or IPS, or Intrusion Protection System. So IDS or IPS system, or IPS. IPS, or intrusion protection system. So IDS or IPS basically allows us to detect bad guys or bad traffic and then do something about it. And I'll give you an analogy that will hopefully help you remember the difference between the two. Think of an IDS as a small dog. You're sleeping at night, sound asleep, and suddenly someone decides to break in. So there's an intruder in your house. What does a small dog do? It sniffs that there's an intruder, and then it barks. In other words, it alerts you that there's an intruder. So it's an intrusion detection system. The dog detects that there's an intruder and then notifies you or alerts you that there's an intruder, and then you can do something about it. An IDS running in a firewall will detect that there's malicious activity on your network and then will alert you.
Detect.
And you need to do something about it. Think of an IPS, or intrusion protection system, as a very large dog compared to an IDS, which is a small dog. An IPS, intrusion protection system, goes a step further. You're sleeping at night. An intruder breaks in. The dog, in this case a very large dog, doesn't just alert you by barking that there's a intrusion, but it also protects you by attacking the intruder. So an example with a firewall would be traffic is going through the firewall. With an IPS, traffic has to go through the IPS system. So the traffic is going through the firewall and the IPS system. When there's an attack, it blocks the attack, so stops it. Whereas an IDS is normally sitting out of band. It's not in the flow of traffic. It's sitting next to it. It gets copies of the traffic and can only alert you that there's a problem. It can't stop the attack. So IPS will stop the attack and IDS will just alert you that there's an attack and you'd have to do something about it. So hopefully that helps you. IDS, small dog, IPS, large dog. Now, many of our devices
Okay, let's go for
such as laptops, MacBooks, and phones don't have Ethernet connectivity. In other words, we are not going to physically connect the laptop or the phone to the network. What we're going to use is Wi-Fi. And I think for most of us, we know what Wi-Fi is. In our home environment, once again, with a little router like this, we'll be connecting to the Wi-Fi router. It'll be taking the signal from Wi-Fi to Ethernet to get us onto the internet and back again, or whatever your WAN connection is. But the idea here is that we are connecting through the air to the network. But at some point, that's going to go through a wired connection, which could be copper, could be fiber, could be something else. Now, these are access points that I'm going to use in the course. From a Cisco point of view, you have what are called autonomous access points and lightweight access points. An autonomous access point basically is configured by itself. It has its own brain, if you like. So this access point would be configured individually. I would connect to it using a web browser as an example and then configure the access point. But if I had many access points rather than just 1 or 3, but let's say 50 or 100 or 500 access points, it's going to be a lot of work to individually configure those access points. So in that case, I want to use what's called a lightweight access point. These are actually lightweight access points. They can function as autonomous access points. But in this example, we are going to use a wireless LAN controller to configure those access points. So rather than configuring, let's say, 100 access points individually or 500 access points individually, we are going to configure them through a controller. We're going yes, large dog. Now, many of our devices, such as laptops, MacBooks, and phones, don't have Ethernet connectivity. In other words, we are not going to physically connect the laptop or the phone to the network. What we're going to use is Wi-Fi. And I think for most of us, we know what Wi-Fi is. In our home environment, once again, with a little router like this, we'll be connecting to the Wi-Fi router. It'll be taking the signal from Wi-Fi to Ethernet to get us onto the internet and back again, or whatever your WAN connection is. But the idea here is that we are connecting through the air to the network. But at some point, that's going to go through a wide connection, which could be copper, could be fiber, could be something else. Now, these are access points that I'm going to use in the course. From a Cisco point of view, you have what are called autonomous access points and lightweight access points. An autonomous access point basically is configured by itself. It has its own brain, if you like. So this access point would be configured individually. I would connect to it using a web browser as an example and then configure the access point. But if I had many access points rather than just one or three, but let's say 50 or 100 or 500 access points, it's going to be a lot of work to individually configure those access points. So in that case, I want to use what's called a lightweight access point. These are actually lightweight access points. They can function as autonomous access points, but in this example, we are going to use a wireless LAN controller to configure those access points. So rather than configuring, let's say, 100 access points individually or 500 access points individually, we are going to configure them through a controller. We're going to use a wireless LAN controller to configure the devices. So in that case, we would connect it to an Ethernet switch such as this one, and then power over Ethernet would be used to power these access points. You don't really want to be going into the ceiling and run power cables to your access points to configure them. You'd rather have them powered through the Ethernet cable. So a switch would provide PoE or power over Ethernet to the access point that powers the access point, but also allows Ethernet connectivity between the access point and the switch and to the controller. So in this course, I'll show you how to set up the WLC or wireless LAN controller so that you can configure the access points. You need to know Wi-Fi for the CCNA exam. It's one area where people seem to really struggle. So I'm going to spend a lot of time showing you how to set this up, and then you can configure it in Packet Tracer as an example. The problem with Packet Tracer is, again, it has some limitations and doesn't set this up properly. So I want to show you with a physical device how it actually works. So in our topology, once again, we've got PCs connected via Wi-Fi to the access point, and the access point is taking the transmission and sending it on the Ethernet network to the internet. So here we've got Wi-Fi, here we've got Ethernet between the access point and the switch, and then between the switch and the router, we'd be using Ethernet typically. And then this could be fiber, it could be Starlink, it could be 5G, or some other technology that gets you to the internet. I think that's understandable for a lot of us. We are connecting using a Wi-Fi device such as a phone to the access point. In this case, it's a router that has an access point built into it. Takes us to the internet using a WAN connection, or we can connect to local devices using the LAN connections. So again, in our topology, here we could have another PC, excuse my bad drawings, but let's say this is a PC, and traffic is going through Wi-Fi to the PC that's wired, and then going back again.
خب درس ما خلاص شد دیگه. چیزایی را که خواندیم، سویچ گفتیم، راوتر بود که routes our internet to the other area, routing from local network to WAN, wide area network, into other network. خلاصه راوتر هم هست که یک رای صحیح را یافت میکنه، یک رای فست یافت میکنه که مو ترافیک ما را راوت کنه یا ترافیک ما را ارسال کنه. و بعد از فایروال خواندیم، فایروال هم هست که it acts like a guard، مانند یک گارد است که نمیمانه مو ترافیک هایی که مثلا از بیرون از اینترنت بیاید. یعنی مثلا مو ترافیک هایی که unsafe هست بیاید بیرون از اینترنت و بیاید نتورک ما رو خراب کنه، یعنی هک ما کنه خلاصه. که دو نوع چی داریم؟ فایروال از IDS و IPS هست. Intrusion Detection System detects in alerts small dog. خب این فقط دیتکت میکنه، سنف میکنه که مثلا اول سنفش میکنه، یعنی سنف بوی کردن است. میبینه که یک دمینیتور داخل نتورک ما یک چیز بد است، یعنی یک گپ شده و بعد از الرت میکنه آدم، فقط الرت میکنه، کدام چیز نمیکنه، فقط مانند مو زنگ قرمز است که مثلا وقتی که چی میشه زنگا شروع به صدا میکنه، هم تک چیز کسی و IPS Intrusion Protection System it does something about it stop، یعنی این مانند یک سگ کلان است، یعنی هم میفهمه و هم یک چیز در مقابلش میکنه که اون را دیتکت کنه و پروتکتش کنه. و بعد از وای فای داریم که وای فای هم میفهمین چی است. وای فای هم ما از طریق خلاصه اینجا گفته بود که وای فای دو نوع وای فای داریم، autonomous in lightweight access points که یعنی بعض پی سی ها که هست از خود چی ندارم و چی میگم RG45 که بالا که میخورم مثلا از طریق وایر ما اینترنت وصل کرد نمیتونیم. خلاصه این وقتا کل پی سی ها چی را نداره پراپرتیز، فقط از طریق وای فای و وایرلس اکسس پوینت میتونن اینا به اینترنت وصل شون. و که اینجا مو چیش نشان دادم مو استراکچر شد، مثلا اول اکسس پوینت، اکسس پوینت هم چی میشه دیگه، مو راوترک میگیم، ما وای فای میگیم، ما اکسس پوینت طریق اکسس پوینتی وصل میشه به اینترنت، یعنی از طریق مو را چی فرکانسی هم از طریق ویو ما از اون طریق ما وصل میشیم و بعد از اون باز این ترافیک ما به سویچ میره و سویچ دیترماین چی میکنه، بعد از به راوتر میره و بعد از به آی پی اس اینترنت پرووایدینگ سیستم سرور چی آی پی اس چی میشد، آی پی اس اینترنت پرووایدر یک چیز میشد، آی اس پی نه آی پی اس میشد. کجا شد آی اس پی، اینترنت سرویس پرووایدر، که بعد از باز میره طرف دیگه. خلاصه ریکپ درس ما این بود دیگه. درس خیلی زیاد بود واقعا، هم 30 دقیقه فکر میکنم، یک ساعت 20 دقیقه شد یا یک ساعت شده باشه که ما ریکارد کردیم و خیلی مسائل رو تشریح کرد و نشان هم داد و ایره ما واقعا هم خوانده بودیم در networking in 20 minutes بود نه. آی پی آدرس، دی ان اس سرور، سابنتس، راوتینگ، فایروالز، هاست فایروالز، نتورک فایروالز، اینا رو خوانده بودیم در networking 20 minutes. ولی اینجا خودش نشان داد کدام دیوایس ها استفاده میشه به خاطر فایروال و هاب چی است، سویچ چی است، دیگه بریج نشان داد، بریج چی است، وایرلس اکسس پوینت نشان داد، وای فای نشان داد، کلش نشان داد و 10 بیس 5 کیبلش نشان داد، 10 بیس 2 نشان داد. یعنی خلاصه به همه نتورک تشریح کرد. سابق چه رقم دال شد دیگه. از خاطر امید که یک چیز را یاد گرفته باشین، ما یکم نوت کردیم دیگه، این نوتا رو باید آدم بخونه و چی و یاد بگیره دیگه. بازم بسیار زیاد تشکر به خاطر دیدنتان دیگه. چرا درسای بعدی رو هم پست میکنیم بخیر و در دید باشید. خدا